So, welcome to Chapter 6, almost there. There's a little bit of review for this one, and it's basically a complete parallel with Chapter 6 of Pre-Cal 11, where you learned about putting the trigonometric ratios together with graphing. So, there's a few terms that we have to remember. Terminal arm, that's this guy. The angle in standard position, that's going to be the angle between the terminal arm and the x-axis, never the y. If it's going counterclockwise, it's positive. If it's going clockwise, it's negative. There's 360 degrees in a circle, that kind of stuff. So we'll just kind of review as we go here. And the first thing that they want us to do in Get Started is to find the coordinates here, assuming that the radius is 1. And that's called the unit circle, and they're going to use it a lot. So you should have a tie-in to a cheat sheet that's got a circle on it and a bunch of different little coordinates and stuff. That's the unit circle. Radius is always 1, and that helps us because then hypotenuse is always 1, and it becomes easier for us to figure out our coordinate points. So we're going to have a look at that right now. They want us to figure out what x and y are for point P if this is 45 degrees. So we can construct a right angle triangle basically by going that's the y and that's the x of this point. And we have one angle here that we know, so we can use the trig ratios. You can use all kinds of fun stuff to get those values. So you might remember from Pre-Cal 11 that sine is always y and cos is always x, because y is the opposite side of an angle in standard position and x is an adjacent side of, or the adjacent side of an angle in standard position. So what we want to recognize here in this triangle is it's a 45-degree triangle, so we can cheat a little bit. And we can recognize that since this is 90 and this is 45, this one will also be 45. And that means this is an isosceles triangle, which means that this side is going to be equal to this side. So we can say that x will be equal to y when that angle is 45 degrees, because an isosceles triangle with equal angles will also have equal sides. Now we can use Pythagoras because we know that x and y are equal. I know that 1 is going to be equal to, well, 1 squared will be equal to x squared plus y squared, but x equals y, so it's actually going to be x squared plus x squared, so 1 will equal to x squared. That means we can continue on with solving for x and divide by 2, get rid of that, and then take the square root of 1 over 2, which gets rid of that, which will lead to the square root of 1 is just 1, so I can solve that out, and it's just 1 over root 2 equals x, but remember that it also equals y. So the point P is going to be 1 over root 2 and 1 over root 2. X and y being equal, and just using Pythagoras and the fact that they're equal. This was kind of a simpler one than some because we can use the x equals y. What you're going to find is that this isn't just something that goes away. You're going to be able to use this in the future, knowing that if you have a 45 degree here, then you will have x and y that are the same here. Also, you can think about what angle would have them kind of like that here, here, and here, and recognize that if the interior angle, the reference angle, is 45 degrees, then you'll know that, let's see, this one, for example, we know this is 45 degrees because that's 45 degrees, so we know that this part is going to be 180 minus 45 degrees, which will give me 135. So what I'll have here is my x value will be negative, but they're going to be equal at 135 degrees as well. So the absolute value is going to be equal, x will just be negative. Down here, I have 45 degrees as well, which means that, well, let's use a different color so we can see it a little better. This one will be 45 degrees, so this angle that comes through here is going to be 180 plus 45, which gives me 225 degrees here, and I'm going to have negative x and negative y there, sorry, at this point. But the absolute value of those numbers will be the same again, because this is an isosceles triangle. So we can do it one more time. At this point, and bringing this one all the way around, sorry, not there, so that it's 45 degrees short, we would have 360 minus 45 degrees, and I'm just kind of using this as a bit of a reminder of how we deal with the quadrants and whatnot. This one we're going to go 180 minus the reference angle, this one we're going to go 180 plus the reference angle, this one we're going to go 360 minus the reference angle because of where they're set up. And so this one's going to be 315 degrees, where you have x is positive, y is negative, but the absolute values will be the same. So quick review of the stuff you learned last year in terms of setting up quadrant 1, quadrant 2, quadrant 3, quadrant 4, and the reference angle, and then being able to spin that reference angle into the other quadrants and conclude similar attributes. So we're going to continue on with this and look at different angles and that kind of thing, but a couple things that are a little bit different. The unit circle has a radius of 1. So last year they used 2 sometimes. This year, the unit circle by definition has a radius of 1. X and y are both negative in the third quadrant. X is negative in the second quadrant. Y is negative in the fourth quadrant. Things to pay attention to. Also, just to throw a couple of review tips in. Y is going to be equal to sine, and x is equal to cos. In this case, using like last year, it would have been y equals sine theta times the radius, but the radius is 1 this year. So I'll just put the theta in there. You go sine of the theta, you get y, because sine theta times 1, no one cares. So this one also, x is going to be cos theta. So those are going to be ones that we're going to use if we don't have this neat, tidy mathematical relationship that we used here to get x and y. We can always use sine theta and cos theta to get x and y as well.